Hi everyone. In this video, we are going to prove a statement which states that sum of first n consecutive odd numbers results into n square. Now what I'm trying to say over here is that if I'm going to add 1 plus 3, which are two consecutive odd numbers, they will add up to 4, which is also a square of 2. If I would add 1 plus 3 plus 5, that will result into 9, which is also 3 square. You can see 3 odd terms results into 3 square. Then you have 1 plus 3 plus 5 plus 7, which is first n or first 4 consecutive odd numbers. This adds up to 16, which is also a 4 square. Now I'm going to prove it with the process of mathematical induction. For the mathematical induction, the first thing we need to realize is that preposition of 1. So I'm going to put 1 in the left hand side. That will be just 1, and in the right hand side 1 square. So they both of them are equal on the either side. We have got 1 is equal to 1. Hence we got proved, and this results true, and it holds good for p of 1. Hence we can say that it holds true for p of 1. Now let it be true for p of k. So I'll just write the statement, which looks like 1 plus 3 plus 5 till so on till 2k minus 1 results in k square. Now this statement is going to help me in further proving that 1 plus 3 plus 5 till so on 2k plus 1. So here we are going to prove it for p of k plus 1, right? Take away 1. So this is what we are going to prove now. Let us evaluate this expression. This will result into 2k plus 2 minus 1, which is equal to 2k plus 1. So the last term is 2k plus 1. And you can see that the difference of 3 and 5 is 2. The difference of 1 and 3 is 2. So these numbers are 2 gaps apart. So what I can write down is that 1 plus 3 plus 5 till so on, and when the last term is 2k plus 1, so the penultimate term will be 2k minus 1, right? Because the difference of 2k minus 1 and 2k plus 1 is of plus 2, right? This should be equal to k plus 1 whole square. So I'm going to opt for a different color pen so that I can highlight what we are doing. Now you can see that I can replace this part by k square, because that's what this first equation states. The sum of first 2k minus 1 odd numbers results in k square, or first k odd numbers results into k square. So I'm going to use it up over here in this one. So I'll replace it by k square plus 2k plus 1 on the left hand side, right? So this is what we wanted to prove. So I'm taking entirely the left hand side that I have. Now k square plus 2k plus 1, if we are going to factorize it up, it will be k square plus k plus k plus 1. From these two statements, I'll take k common, and from these two terms, I'm going to take 1 common. So I can further factorize it to k plus 1 times k plus 1, which is equal to k plus 1 square, which is also equal to the right hand side of what we are going to prove. So this is how we prove it for the given statement P of k plus 1. Hence, it holds true for P of k plus 1 as well. Hence proved.